Lesson 33 covers factoring the greatest common factor, or GCF. In example A, you have a binomial. You need to factor out the greatest common factor. Basically what happens here when you're factoring, it's almost like working the distributive property in reverse. You're looking at the term, the binomial, and figure out what can you take out of each term. First off, take it with the numeric version first, 36 and 27. If you don't know what the greatest common factor is, I use what's called the L method, or upside down birthday cake. If you're not sure how to do it, it looks something similar to this. Now, you're not going to have to do this for too many problems. I'm just showing you that this would work. A lot of you could already identify that 9 goes into both of those. Let's say you didn't. Let's say you go ahead and you choose a 3. Well, 3 goes into 36 12 times. 3 goes into 27 9 times. Now, in 12 and 9, you can still take a 3 out of that. So I'd make another layer, hence the cake. We get a 3 here, we get a 4 there, and a 3 there. Nothing can go into 4 and 3 evenly. So basically on the side here, if you multiply those terms, you would get 9. That would be your greatest common factor, and many of you identified that right away. So your greatest common factor is 9. Then the next thing that you would take out of this is look at your y values. You have a y squared and a y. The most that you can take out of that is a y, because you have to be able to take out of all of your terms. So I would factor out a y. Now basically you have stuff left over. Well, if you factor out a 9 out of 36, you're left with 4. You had a y squared, you factored out a y, you're left with a y. It is adding, so plus. When I factor out a 9 out of 27, I'm left with 3. And then again, when I have a y here, I factor out a y, I have nothing left. Way to check your answer would simply be to go ahead and distribute your 9y back into everything, and you should get your original answer. So when factoring our GCF, this is basically what we would come up with as our answer here for example A. 9y would be our greatest common factor that we factored out. Example B here, again, work from the numeric version here first. So you basically have 8, a 16, and a 2. Should be pretty evident what your greatest common factor is. One other note I'm going to let you know here is when this leading coefficient, the leading term is negative, I like to factor out a negative. So in this problem, 8, 16, and 2, I'm going to factor out a negative 2. Then I'm going to look at my a terms. Well, I have a squared, an a, and an a. So I can factor out 1a there. And then I'll look at my b terms. Well, I have a b, b squared, and b. So I'm going to go ahead and factor out a b. That would be my greatest common factor. Now in my set of parentheses here, this was a negative 8a squared. It is now going to be a positive because I factored out a negative. So I'm going to have a positive. Well, when I factor out of the 8 there, I took out a 2, so this is basically going to become a 4. I had an a squared, I now have an a. I had a b, and I factored out a b, so there's no b's left. Again, factored out, this is really a negative 16. Well, I factored out that negative 2, so this would be a positive. And this would be a positive 8, because when you take negative 2 times 8, that's going to give you that negative 16. You have an a, you factored out an a, so there's no a's left. You have a b squared, you factored out a b, so there is a b left. And then we have a positive 2. Well, we factor out a negative 2, so it is now going to become a negative sign. And when you factor out a 2, 2 would be gone. You would have a, you factored out an a, so a is gone. You had a b, you factored out a b, so b is gone. So we're going to go ahead and put a 1 there when you factor everything out. That way when you distribute that term in, you would wind up with the original term. So our answer here for b is negative 2ab, and in our set of parentheses would be 4a plus 8b minus 1. Next two examples, we're going to go ahead. I want you to pause the video here and try to work through a few of these on your own. So again, start out with your numeric value. figure out what you can factor out numerically, and then see if you can factor out a variable. So go ahead and pause, work through example D. Alright, now we're back here. Numerically, we should have factored out a 3, and then when we factored out a 3, there's nothing variable-wise that we can factor out with being a w and an x. So when we factor out that 3, we should have had 5w minus x. Last example, example E. Again, pause the video if you haven't and work through it. Alright, we'll check her out here. First thing, numeric values 7, 21, and 1. Nothing you can factor out numerically, so then we could go ahead and factor out a variable here. We have x squared, x, and x, so we should be able to factor out an x out of each one of those terms. And then you can look at your y's, y squared, and y, and you would be able to factor out a y out of each one of those terms. After you factor out xy inside of your parentheses here, you should have 7xy minus 21y minus 1. This will conclude lesson 33.